Welcome to the Podkey summary of Build Real-Time Apps and Services with gRPC and Swift from WWDC 2026. Today's catch-up is really about one idea from a few angles. gRPC Swift is a lot more than a niche networking tool, and the case for it gets stronger once you care about performance, streaming, and real app behavior. There's a clear contrast with OpenAPI and REST, a practical story around protobuf efficiency, and some very usable lessons on client reuse, deployment, and production features. And maybe the biggest signal is that Apple is using this stuff all over the place, which usually gets people's attention pretty fast. A good starting point is the difference between gRPC and OpenAPI code generation, because they solve similar-looking problems in pretty different ways. With gRPC, you define services and messages in protobuf, generate Swift client code, and you can start calling those services without hand-building a bunch of networking plumbing. OpenAPI also generates code, but it's aimed at HTTP-based APIs, so the model still feels tied to endpoints, requests, and the usual REST shape. The argument here is that gRPC's function-style model is often cleaner. You call a service method with an input message and get an output message back, and that can be a nicer mental model than stitching your app around URLs and verbs. That especially matters once the conversation stops being simple, request, response, and starts becoming ongoing real-time communication. REST can do a lot, sure, but gRPC is built for that world instead of being politely dragged into it. The other big piece is protobuf itself. Protobuf messages use numeric field identifiers instead of shipping verbose field names around in plain text, so the payloads end up being roughly half the size of equivalent JSON. On mobile networks, that matters. Smaller payloads mean less data to move, less waiting around, and a better fit for low bandwidth or flaky conditions where every bit of overhead becomes annoyingly real. And it's not only a phone-on-cellular story. Smaller binary messages are useful for service-to-service communication and even inter-process messaging. One example that stood out is Apple's containerization framework, which uses gRPC Swift over virtual sockets between the host OS and Linux virtual machines. That's a nice reminder that efficient serialization is just as valuable inside systems as it is over the internet. gRPC also gets interesting because it doesn't stop at one RPC style. You've got unary calls, which are the familiar one request, one response shape, then client streaming, server streaming, and bidirectional streaming. Client streaming showed up in the example of telemetry coming from go-karts. That makes sense right away. The client keeps sending measurements over time instead of pretending each update is a whole separate little universe. Server streaming was illustrated with live text commentary, where the client asks once and then keeps receiving updates as they happen. And bidirectional streaming is the most flexible of the bunch. The race example had the client dynamically changing which events it cared about while the server continued sending relevant updates back. That's the kind of interaction where gRPC feels very natural. You're not faking a conversation through a stack of repeated HTTP requests. You just have a conversation. There was also a very grounded app design point here that's easy to miss if you only think about the protocol and not the actual client behavior. If you create a brand new gRPC client for every SwiftUI view, you keep paying connection setup costs over and over. That adds latency you don't need and burns resources for no good reason. Sharing a single client through the SwiftUI environment is the better pattern. It cuts down round-trip time and keeps connection management sane. And just as important, the client gets disconnected when the app moves to the background. That lifecycle handling is one of those details that doesn't sound glamorous, but it's exactly the kind of thing that separates a demo from an app that behaves well in the real world. The follow race bidirectional RPC had some nice implementation detail behind it too. On the server side, the code has to deal with an async sequence of incoming request messages and an async writer for outgoing responses. So both directions are active, and both need coordination. The approach uses Swift task groups along with a mutex-protected set of subscribed events. The server first waits for the initial request, so it can figure out which race the client is actually talking about. After that, it can concurrently track live race events, update the mutable subscription set as the client changes interests, and only write back the messages that match what the client currently wants. That's a pretty clean example of how bidirectional streaming becomes stateful in a useful way. The stream isn't just open, it's adaptive. Deployment got a practical treatment too, and it was refreshingly straightforward. The server is built into a Docker image with a multi-stage container setup. Compile everything in a full Swift toolchain image, then copy the finished binary into a much slimmer runtime image. That keeps the final image smaller, which is usually a very good sign that future you won't be staring at a bloated container, wondering how things got so weird. From there, the image is pushed up to Google Cloud Run, and the service is configured for HTTP/2 and TLS, so it can actually serve gRPC properly in production. So this isn't presented as theory, it's a workable pipeline for shipping a gRPC Swift service. Probably the strongest credibility marker in the whole discussion is how deeply gRPC Swift is used inside Apple. It powers parts of private cloud compute, iCloud keychain, photos, SharePlay file sharing, and even OS build and release pipelines. That's a wide spread. Consumer features, infrastructure, internal systems, all of it. And again, containerization shows up here too, with gRPC Swift handling communication between the host and Linux VMs. So the picture that emerges is versatility. This isn't boxed into public API clients or one narrow category of back-end work. It fits external services, internal services, and system-level communication. Beyond the core RPC features, the ecosystem around gRPC Swift sounds pretty mature. There's integration with Swift OpenTelemetry for observability, service lifecycle management, custom transports, name resolvers, and client-side load balancing. That means the conversation can move past, can it make requests, and into the more grown-up questions, like how you monitor it, how you scale it, and how you make it resilient when the network inevitably gets creative. It also matters that the project is open source. The invitation here is broad, from improving docs all the way to implementing new features, which gives developers a real way to influence where the library goes next. So the short version is, gRPC Swift looks compelling when you want strong code generation, efficient binary messages, and streaming that feels native instead of improvised. And once you add real deployment patterns and Apple's own usage, it starts to feel less like a neat option and more like a serious part of the Swift toolbox. That's a pretty solid place to leave it. Small payloads, fewer fake conversations, and ideally fewer unnecessary clients being spun up in random SwiftUI views. This episode was generated by Podkey. Create your own at podkey.fm.